Alright, here are the examples or sample problems related to our topic, um, transient circuits. So again, though, the items I taken from our workbook, Engineering Differential Equations by Bravo, Cruz, and Gomez. So let's try to solve example or item number 1, page 95 of our book. A resistance R, which is 10 ohms, and a capacitance C is 4 millifarad are connected in series with a direct current element E is equal to 50 volts. Assume that when the switch is closed, the charge on the capacitor is 0.02 coulomb. So, ito yung sinasabi ko kanina na the charge in the given capacitor is always assumed to be 0 unless we are told to do so. So at time t is 0, the charge in the capacitor is 0. So ibig sabihin pag hindi sinabi, it is assumed to be 0. But in this case, at time the switch is closed. So ibig sabihin at time t is 0, our capacitor's charge is 0.02. So meaning to say, hindi na short or na discharge yung charge in that particular capacitor. So we are looking for the initial current. So ang initial condition natin that at time t is 0, the charge in the capacitor is 0.02 coulomb. So that's our initial condition. So the problem says that this a 50 volt source, say this is your switch, this is the resistance R, which is 10 ohms, and I have here a capacitor C, which is 4 millifarad. So again, when the time the switch is closed, there exists the current. So again, by KVL, so we have E is equal to, so remember our voltage E is 50 volts, is VR plus VC. So we have 50 is equal to R, which is 10 times the current, that's IR, plus Q over 4 millifarad. So 4 milli is times 10 to the negative 3. Pag inangat natin, magiging times 10 to the third, which is 1,000 divided by 4 is 250. So 50 here is 10I plus 250Q. But then again, I is dQ dt. So substituting dq dt there, so that gives you 50 is equal to 10 dq dt plus 250 q. So by dividing this all by 10 and rearranging, that gives you dq dt plus q multiplied by 25 is equal to 5. So again, I divided this all by 10. So let's multiply it by 1 over 10. So this 1 over 10 times 50 is 5. Then 250 divided by 10 is 25. And then this becomes dq dt na lang. So this is again first order linear differential equation. So whose integrating factor IF is e to the 25t. So since we are to integrate e to the 25 dt, e to the integral of 25 dt, so which is equal to e to the 25t. So nanggaling yun sa e to the integral of 25 dt. So since that's our IF, so the simplified IF is e to the 25t. So multiplying this all by e to the 25t, so our Q e to the 25t derivative, so multiplying our LDE by our integrating factor, that is derivative of the product of the dependent Q and our integrating factor e to the 25t equals 5 e to the 25t. So integrating the 2 gives, so I need to provide here 25 and compensate with 1 over 25. So your q e to the 25t here is equal to 1 over 5 e to the 25t plus k. Then q is 1/5 plus k e to the negative 25t coulomb. So that's our initial condition, general solution. So from our initial condition, it is said in the problem that at the time the switch is closed, the charge in the capacitor is 0.02. So at time t is 0, my q is 0.02. So coulomb. So 0.02 is equal to 1 over 5 plus k e to the 0. So this is equal to 0.02, which is 2 over 100, which is 1 over 50. So therefore, your k is 1 over 50 minus 1 over 5. So because e to the 0 is 1, so times k, and transposing this 1 over 50, 1 over 5 to the right side of the equation, so that gives you 1 over 50 minus 1/5. So that's negative, because your LCD is 50, that's negative 49. No, it's negative 9 over 50. So negative 9 over 50. Because 50 divided by 50 is 1 minus 50 divided by 5 is 10. So 1 minus 10 is negative 9. So your k is negative 9 over 50. So q is 1/5 minus 9 over 50 e to the negative 25t coulomb. So that must be the expression of our q. So that's the charge at any time t. So say for example, if you're given a time t is equal to 2 millisecond, what must be our charge? So you just have to substitute and plug it into our expression. But the problem here is we are looking for the initial current. So the initial current, find the current at time t is equal to 0. So initial current at time t is 0. What is the value of the current? So I just need to take the derivative. I is the derivative of q with respect to t. So that's the derivative of 1/5 minus 9 over 50 e to the negative 25t with respect to t. So that gives you derivative of 1/5 is 0. Derivative of negative 9 over 50 e to the negative 25t is negative 25t times negative 25. So this gives you negative times negative. That must be positive 9 over 2. So I of t is therefore equal to 9 over 2 e to the negative 25t ampere. So since we're looking for the initial current at time t is 0, this is 9/2 e to the negative 25 times 0 ampere. So I of 0 is therefore 4.5 ampere. So at time t is 0, or the initial current, the current through the capacitor, or the capacitor, is 4.5 ampere. So let us try to solve. Next, a constant voltage is applied to a series circuit by closing a switch. This is number 2, page 95. So a constant voltage is applied to a series circuit by closing a switch at time t is 0. A voltmeter tapped across L. So meron tayong E, we have R, and we have L here. So I forgot again our switch S to be closed later. A voltmeter tapped across L registered a reading of 120 volts at the instant the switch is closed. So ibig sabihin, there is a voltmeter tapped across the inductor at time t is 0, So the time the switch was closed, registers 120 volts. So meron tayong 120 volts at the time na magkakaroon siya ng current nung na-switch yung close. Na-close yung switch. Said voltmeter reading dropped to 24 after 25 milliseconds. So, ibig sabihin, at time t is 25 millisecond, voltage is now equal to 24 volts. We are looking for the value of R when L is 0.2 Henry. So, since we are talking of VL, so we know that VL is L times the derivative of I with respect to t. So if we try to go back to our discussion earlier, we have actually derived the relationship ng ating I kapag ka meron tayong RL circuit. So you just have to review it na lang. And then, since I is E over R times the quantity 1 minus E to the negative R over LT, I just need to copy it here and take its derivative and multiply to L to solve for VL. So this is therefore equal to L times the derivative with respect to T of the expression I for any RL circuit in series. So you have here E over R times the quantity 1 minus E to the negative R over LT. So, L times the derivative of I. So, this is actually my I of T. So, since ang given kasi natin dito is voltage across the inductor eh. So, we need to get the voltage across the inductor. So, since VL is defined as L times the derivative of I, as per solved a while ago, I is E over R times the quantity 1 minus E to the negative R over LT. So, taking its derivative and multiply it to L, that therefore is your VL. So, VL here, simplifying, L times the quantity E over R times the derivative of 1 is 0 minus the derivative of E to the negative RL is negative E to the negative R over LT multiplied by negative R over L. So, this R cancels out, this negative and negative becomes positive, and since this is preceded by L here, so that gives you L cancels out also. So, your VL is actually defined as E to the negative R over LT multiplied by our voltage input, E. So, from our initial condition, it is said that at the time a switch is closed, at time t is 0, voltage across the inductor is 120 volts. So, ibig sabihin, if I'm to substitute at time t is 0, voltage across the inductor is 120 volts. So, substituting 120 VL is equal to E to the negative R over L multiplied by 0. So, therefore, we will have E as 120 volts. So, ibig sabihin, at time t is 0 again, E times E to the negative R over L multiplied by T, since that's 0, meron tayong value. That is E, which is 120 volts. So, second condition. Ang sinabi sa second condition that at time t is 25 millisecond, your VL drops to 24 volts. So again, Substituting, VL is 24 volts. So from VL is equal to E to the negative R over LT. I just need to substitute our given again. So VL is 24. Our E as per solved is 120. E to the negative R over L multiplied by 25 millisecond. Simplifying, that is 24 over 120 is equal to E to the negative R over L multiplied by 25 millisecond. So 24 over 120 is, so we have 24 divided by 120 is 0.2. So this is 0.2 is E to the negative R over L, 25 millisecond. So solving for R over L, so that gives you negative R over L multiplied by 25 millisecond. ln of E is ln 0.2. So by applying natural logarithm on both sides, so this negative R over L times 25 millisecond must be put here. ln E is equal to ln of 0.2. But ln E is 1. So this gives you negative R over L multiplied by 25 millisecond is equal to ln of 0.2. So since we are looking for the value of R, for L is 0.2, I just need to transpose, cross multiply and divide by 25 millisecond and divide by a negative number to solve for the value of R. So your R here, so let me just rewrite it. Negative R over L times 25 millisecond multiplied by L is equal to ln 0.2. So cross multiplying, dividing by negative, and divide by 25 millisecond to solve for the value of R. So that's negative ln 0.2 over 25 millisecond multiplied by L. L is on the numerator. So I just have to put a negative na lang para maangat ko siyang ganun. So cross multiply. So R here is negative L ln 0.2 over 25 times 10 to the negative 3. So L here is 0.2 as per given. So that's R equal to negative 0.2 ln 0.2 over 0.025. So that is, you move the 3 decimal places sa pakaliwa. So this is ln of 0.2. So you have ln of 0.2 multiplied by negative 0.2 is equal to 0.32 divided by, equals muna tayo. Equals divided by 0.025. So that gives you R equal to 12.8755 ohms. Or R is 12.88 ohms. So that is the value of R. So that's the answer there. R is 12.88. So ang sabi dun sa number 3, page 95, at what instant after closing the switch would the voltage across R be equal to that of the voltage across L? So meron tayong second question sa number 3, at what instant daw that the voltage across L be equal to the voltage across R? Okay. So, kailan daw magiging ang VL is equal to VR? So, again, as per solved, VL is e to the negative r over LT. So, that's what we have solved a while ago, that VL is e times e to the negative r over LT. VR is equal to r multiplied by I. What's the value of I again? The value of I here is e over r times the quantity 1 minus e to the negative r over LT. So, at what instant daw that VL e to the negative r over LT times e is equal to VR, which is, remember, this VR is equal to I multiplied by R. So, R is there and I is this one. This is the expression for R in the NERL circuit. So, simplifying this VR, that R cancels out. So, this gives you E times the quantity 1 minus e to the negative R over LT, which is equal to e to the negative r over LT. So that's the question At what time daw that voltage across L is equal to voltage across R? So since VL is equal to VR, that E and E cancels out, dividing both sides, that gives you e to the negative r over LT is 1 minus negative r over LT. So transposing, that gives you 2 negative r over LT is equal to 1. Then e to the negative r over LT is equal to 1/2. So, taking the natural logarithm on both sides, ln e to the something is something, so that gives you negative r over LT is equal to ln of 1/2. So, solving for the value of L, you cross multiply. So this is negative RT. No, we are to solve for the value of T, I mean. So we are to solve for the value of T. Ang question kasi is at what instant? So L is given. So T here is equal to negative L over R, ln of 1/2. So your T here is equal to negative 0.2 over 12.88 multiplied by ln 1/2. So that is negative 0.2 multiplied by ln of 1/2 is 0.5, close, divided by, equals muna tayo, divided by 12.88. So let me use 12.8755. 12.8755 para more accurate ang makukuha nating sagot. So that is equal to 0.01076691671 second, or that's t equal to 1, 2, 3. So 3 to the right is 10.77 millisecond. So that is our answer. So that is, at that very instant, the voltage across the resistor is equal to the voltage across the inductor. So that answers question number 2 and number 3. So 12.88 ohms, and at time t 10.77 millisecond, the voltage across the inductor is equal to the voltage across the resistor. Okay, example number 4. Let me answer number 6, page 95. It is said there that a 90 volt EMF is applied to a series RL ulit. So meron tayong 90 volt daw source, an RL circuit. You have R and an L. So L is 1 Henry and the resistor is equal to 100 ohms. Find the current at time t approaching infinity. So again, current, ang hinahanap, meron na tayong na-solve na expression kanina. I is, what's the value of I? This is capacitor. So, I of t is E over R times 1 minus e to the negative R over LT ampere. So, we are looking for the time it approaches infinity. Substitute lang natin dun sa ating given. So, this is E over R times the quantity 1 minus e to the negative R over L multiplied by infinity. So, ampere. So, negative times infinity is negative infinity. So, that gives you E over R, 1 minus e to the minus infinity. E to the minus infinity is equal to 1 over e to the infinity, which is actually 0. So, this is 0. And that gives you I as t approaches infinity is simply the ratio of the voltage source to the resistance. So this is simply 90 volts divided by 100 ohms. So therefore, I as t approaches infinity is 0.9 ampere or 900 milliampere. So